Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome again, dear grade 8 students. In the previous videos, we talked about relative positions between lines and a circle. And here, in this video, as I promised, I'm going to talk about relative positions between two circles. As you see here, let's start with the first relative position between these two circles. These two circles are disjoint circles. There are no common points in between them. As you see, the purple circle, C, and the green circle, C prime, are disjoint. There is no point of intersection between them. So we call them externally disjoint circles. So these are externally disjoint circles, or some call them exterior. Okay, now let's make a little bit revision to how to represent a circle. Here, as you see, this circle C, the purple one, is represented as follows. Capital letter C, we pop in parentheses. O is for the center, and the radius here measures 1, 2, 3, and 4, and the radius is 4. According to the green one, the circle that's green is represented as follows. C prime, we call the C prime, we open parentheses, its center is, as you see here, O prime, and the radius R prime measures 1, 2, 3. We are going now to take into consideration the radii, and we are going to compare the distance between these centers and the radii. According to this figure and to these circles, we notice that the purple circle and the green circle are disjoint. Moreover, the centers O and O prime are, let's count, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the distance between the center O and the center O prime is 9 centimeters. So O and O prime are 9 centimeters apart, and that distance is greater than the sum of the radii, because the first radius is 4 and the second radius is 3, and their sum is 7. We notice here that 9, which is the distance between the centers, is greater than the sum of the radii. That's according to externally disjoint circles. The distance between the centers O and O prime is greater than the sum of the radii, and that's obvious because you notice here there is a space that measures 2 centimeters between these two circles. So from here to here we have 4 centimeters. From here to here we have 3 centimeters. This is 7. And the space that measures 2 centimeters is the reason why we get 9, which is greater than the sum of the radii. So that's according to externally disjoint circles. Now, if I move this circle to the inside like this, and that's R prime. Okay, the radius O prime from here to here is R prime, and here is the circle C prime. We notice that again the circles are disjoint. There is no point of contact between them, whether we make it like this or like this. Notice there is no point in contact between them. Okay, now let's compare the distance between the two centers and the radii. O and O prime here are less than 1 centimeter apart. From here to here is 1. This square measures, the side of this square measures 1 centimeter, while O prime, so if you notice here, O prime is less than 1. What is 1? 1 is the difference between the radii. Of course, we put the large radius minus the small radius. The large radius R is 4, and the small radius R prime measures 3. Their difference is 1. We notice here that O and O prime are less than 1 centimeter apart. Notice that distance is surely less than 1 centimeters apart. These two circles here are called internally disjoint. They are disjoint but internally. So these are called internally disjoint circles, and some call them interior circles. That's according to internally disjoint circles. The distance between the centers is less than, so the distance between the centers O prime is less than the difference between the radii. Surely we put the larger radius minus the smaller one, while in case we have externally disjoint circles, we notice that the distance between the centers is greater than the sum of the radii. That's according to internally disjoint when the circle is inside and not intersecting the other circle, and that's according to externally disjoint when the circle is outside and not intersecting the second circle. Now, what happens if the circles intersect at just one point, as we see here? That's C prime and that's C, and these two circles are intersecting at a single point. Let's make it larger. So here is a single point of contact or point of intersection that we call the point of tangency, because these circles are said to be externally tangent circles. So these circles are said to be externally tangent circles, and that's called the point of tangency. And notice that the point of tangency is collinear with the centers O, A, and O prime are three collinear points. So that's the point of tangency. Okay, when the circles are just intersecting at a single point, we call it the point of tangency, and the circles are called externally tangent. Now, what about the distance between the centers? O prime is exactly equal to R plus R prime, because as you see here, 4 plus 3 is exactly the distance between O and O prime. So here we have 4 centimeters, no space in between, and here we have 3 centimeters. Then definitely we notice that O prime is exactly 7, which is exactly equal to the sum of the radii together. That's according to externally tangent circles. Now, what happens if the circle keeps moving until it contacts the other circle at a single point but internally? So here is another point of contact, which is a single point also, and it's called the point of tangency as well. And here is R prime, the larger one is R, and here is the circle, the green circle, C prime. And that point of tangency is also collinear with the centers. Let's call it A again. That's the point of tangency, as I told you just right before. And here we have to call these circles internally tangent circles. So these are called internally tangent circles, and that's the point of tangency. And let's notice something concerning the distance between the centers. O prime is exactly, if you count the distance or look at it here, O prime, that's O prime, is exactly 1. What is 1? 1 is exactly 4 minus 3, which is the difference between the bigger radius and the smaller radius. So that's the relation between the centers when the circles are internally tangent circles. So the distance between the centers is exactly equal to the difference of the radii. We put the larger radius minus the smaller radius. That's according to internally tangent circles. So we talked about, let's make a little revision. We talked about externally disjoint circles, internally disjoint circles, externally tangent circles, and internally tangent circles. What do we have also? Let's continue relative positions between circles. We have, guess what we have? The intersecting circles. Notice here is the radius r prime, o prime a, and here is the radius r. Here is a point B, and here is the point A. These are the 2 points of intersection between these 2 circles. So 2 circles, when they intersect at 2 points. Okay, so 2 circles intersect at 2 points. Here I call them A and B. We can call them any letter we want, but here I call them A and B. So there are 2 points of intersection between 2 circles. Now let's make a relation between the centers in this case and the radii. Notice the distance between the centers. 1, 2, 3, 4, 5, 6. Let's mark 6. Let's change that distance. The distance between the centers, O prime, 1, 2, 3, 4, 5. Let's mark this number. 5. Let's move it a little bit. For example, here, the distance is 1, 2, 3, 4, 5, 6 and a half. Let's say it's 6 and a half. So we write 6 and a half. Let's move it a little bit. For example, 1, 2, 3, 4 and a half. The distance O prime is 4 and a half. Now we are not getting an exact distance, okay, but we can notice that every time the distance between the centers is bounded between, let's notice that it's bounded between 7 and 1. So the distance between the circles, the centers of the circles, even if we put it like this, even if we make the intersecting like this, notice the distance between O and O prime is 1.5. Let's mark this also. For example, it's 1.5. These are intersecting circles and the distance between the centers is 1.5. So, dear students, every time we are making intersecting circles, the distance between the centers is bounded between 1 and 7. What are 1 and 7? What are 1 and 7? 1 is 4 minus 3. And 7 is 4 plus 3. Why am I talking about 4 and 3? Why am I concerning 4 and 3? Because 4 and 3 represent the radii we have. The big radius is 4 and the small radius is 3. That's why the rule says that when I have intersecting circles, then the distance between the centers is bounded between the difference of the radii. It's bigger than the difference of the radii, of course, the bigger one minus the smaller one, and less than the sum of these radii. And that's a property in a triangle as well. If I have this side and this side, then definitely the third side is bounded between the difference of the sides and the sum of the sides. That's according to intersecting circles. Also, in intersecting circles, the line holding the centers is considered as an axis of symmetry. So the line holding the centers is considered as an axis of symmetry, which means that when I consider that as a paper and I fold the upper part again towards the lower part, I can notice that this part will coincide with this part and this part will coincide at this part. Moreover, if I join this point to this point and this point to this point, I'm going by symmetry to get that this angle is equal to this angle is equal to this angle. The sides here up and down are equal also, and this angle is definitely equal to this angle due to symmetry, because the line holding the centers is considered as an axis of symmetry. That's according to intersecting circles. Now, if the circles are intersecting but equal, so I'm going to change the radius of the purple circle to 3 to make them equal intersecting circles. So if the circles are intersecting but equal, as you see here, these are intersecting circles, but they are equal as well. They have equal radii. That's what we mean by intersecting circles that are equal. So the radii are equal. Here r is 3 and here r is 3. What do we notice? We can notice that when the circles are equal intersecting, then also we have that the line holding the centers is an axis of symmetry, and also the line holding the intersection points is also an axis of symmetry. So if we fold it upside down, this part will coincide with this part, every part up will coincide with every part down, and if we fold it from right to left or from left to right, we will get that all of these parts here are going to be coinciding with these parts here. That's what we mean by axes of symmetry. So we call these lines axes. The plural of axis is axes of symmetry. Okay, so the line holding the centers is an axis of symmetry, that one, and the line holding the intersection points is an axis of symmetry. While if the circles are not equal, I will return it to radius 4. If the circles are not equal, they don't have equal radii, notice that this blue line here holding this intersection points is not considered as an axis of symmetry. Well, it's clear that this part will never coincide, this part to the right will never coincide with that part to the left. Just the line holding the centers is only the axis of symmetry. So when is the line holding the intersection point an axis of symmetry? It is an axis of symmetry when the circles are equal and intersecting at the same time. Okay, that's according to intersecting circles. Now we are going to talk about special kinds of circles. First of all, I'm going to talk about the concentric circles. So concentric circles are circles having different radii, but they have exactly the same center. So these are called concentric circles. So these are concentric circles. They have the same center, but they don't have the equal radii. Here is the smaller radius r prime, and here is the bigger radius r, and here is the circle c prime. These are concentric circles, and if the green one is going to have a radius 4, so we have concentric circles that are equal, then we will get confounded circles. So concentric circles of equal radii are called confounded circles. They are concentric, having the same center, and they also have the same radii. So C and C prime are, we represent it like this, are confounded. C and C prime are confounded. We represent it that way, circles. Okay, so these are relative positions between circles. Hope you enjoyed them, and meet in other videos, inshallah, making a summary about relative positions between circles.